or not. Okay, so this is a part 2 of that problem that we didn't finish. This is the equation e to the y times dx plus x e to the y plus 2y dy equal to the 0. Okay, the differential formula. Want to check to see if this equation, you see, it doesn't matter. This equation would be given to you and they ask you to solve it, for example, in general. First thing you check to see if it's going to be separable variable. You see, in the case of the separable variable, it's not. That's the second one. You see, they are not factors. To be able to factor it out, make it to the function of x times y. So that is your first checking. Then you go to the linear equation. Linear equation is easy to check. Y prime, you know that, dxy equal to the q. So it's not separable. It is not linear, so you check to see if it's going to be exact equation. That's exactly how we do the problems. So for the exact, you know that you call this one m, and this is going to be your n, and you check the condition to see if the condition is satisfied. So the solution is going to be, call this function to be m. The one that you call m, you are going to find my, partial derivative with respect to the y. Okay, it's an exponential function, nothing changed. So my would be just e to the y again. Then you pick the n. Your n is x e to the y plus 2y. From here, you're going to partial derivative with respect to the x. So you see the derivative of x would be 1, e to the y is just a coefficient. So it's going to be e to the y. And in this case, 2y would be a constant. It's isolated, so derivative is 0. So as you can see, my is equal to the nx. So the equation is exact. Okay, so it is an exact equation, just for your information. So as soon as it's the exact equation, you have to find a function f. Okay, a function f with this condition, round f over round x to be m, okay, and round f, round y to be n. So this f is missing. That's the way we do it, potential function from that point. So form this system of the equation and solve it. Okay, so it's solving it. We are going to round f, round x, you let it equal to the m, which is e to the y. Round f, round the y, letting to be equal to the n, which is going to be x e to the y plus 2y. Equation number 1 and number 2. Okay, it's a system of partial differential equation. You start with one of them integrating, but since you partially integrating, there is going to be a constant that can be a function of that, the other variable. So for example, if you start with number 1, partial differential equation with respect to the x. So we are going to have, so from 1, I integrate with respect to the x, I get f of x, y, equal to the integral of e to the y dx. E to the y would be constant, okay? So you're integrating 1. Integral of 1 would be x, so this would be equal to the x e to the y, but there is a constant. Since you integrate with respect to the x, that constant would be maybe a function of y. So we're going to say that x e to the, okay, I integrate with respect to the x, so I can have g of y here. Okay, any question? Yes.
Could it also be called cy?
You can call it cy, yeah, doesn't matter. It's a function. Okay, so so far, we get f of x, y is equal to the x e to the y plus gy. Now, from now on, you have to decide what is g of y. You have to check to see if there is anything. If it's going to be constant, you can leave it. Okay, but you have to check it. In order to check it, you go to the second equation. Okay, in the second equation, you have derivative with respect to the y. So differentiate this one with respect to the y. Okay, so that give you what? Round f round y is going to be derivative of this one with respect to the y. E to the y is e to the y. X is the coefficient, it's going to be x e to the y. And derivative of the second one with respect to the y would be simply g prime of y. Okay. So, but remember, you have round f round y from the equation number 2 as well. Okay, so you bring it down. So from 2, I have a round f round y is equal to the x e to the y plus 2y. Okay, now you let them equal to each other. We're going to drop the common terms. You see these two are the same, these two are the same. So the other two must be the same too. So the leftover is going to be g prime of y must be equal to the 2y. Any question? Now you're integrating respect to the y. G prime of y equal to the y, so g of y is going to be integral of 2y dy. Integral of 2y dy, you know that's going to be y squared. Okay, we are looking for 1g. So we don't write y squared plus c. So g of y is equal to the y squared. So go back and substitute for g of y into the function that we got it over there. So f of x comma y is going to be equal to x e to the y plus y squared. So this is going to be a kind of potential function, a function that satisfies that condition. But you know that differential of this function is 0, so this function is going to be a constant function. So you let it equal to the c, that give you the solution of the equation. So the solution, the general solution is when you let f of x comma y to be equal to the c, a constant. So x e to the y plus y squared equal to the c is going to be the final answer. You're going to find the y implicitly. You're not going to have y equal to. Okay, there is a y, it's inside. Go and find it. Okay, so it's very straightforward problem among the one that we have. Any question? So if you start with the equation number 1, your constant will be a function of y, g of y, c of y. If you integrate the second equation, so your integral would be, your constant would be, respect to the x. You have 4 in that practice one. We're going to check it. We give you 1. Any question? Now, in problem that you are going to have in application problem, especially several cases in physics, and if you do something like electrical engineering, you see the type of equation that they are not going to be exact. They are not going to be exact, but you may be able to change it to the exact equation. In order to do it, sometimes we multiply by a function. Multiply a function, both sides of the equation, so that you are going to get an exact equation. If you can find this function refer to it as integral factor. Okay, so there are several ways to do it. There is a table, depends on the application that we're going to have, several cases that's known. The cases that are going to be known and it can be done are going to be the one that if you can guess that you can find an integrated factor, which is going to be a function of x only, like y over x, x squared. You may be able to find a function that's going to be only the function of y. It's another one. You may find a function that's going to be a function of x times y. You see x squared, y squared, x cubed, y cubed, these type of problems. The function x squared plus y squared, x squared minus y squared. If you are going to be in future, you will have these type of disciplines. You have a chart, you have a look at it, and you find out. So what we're going to do, we are going to consider only 2 cases for you. I'll go with your book. I usually go with the 3 cases, but 2 cases with 1. We are going to show you, I show you a general method that you can find it yourself in future. You can prove all of those charts that would be given to you. So we are going to give only two cases that integrating factor can be a function of x or a function of y. So when we give an equation, we ask you solve this differential equation by finding an integrating factor. So I'm going to create a situation for you, I prove it. Give you two conditions. So you apply those conditions to the equation, you will find out whether you are going to have, okay, integrating factor with respect to the x or y. That give an idea in case in future you need more, then you can do that one too, okay? So what is going to be, this is going to be your last question that you're going to have in this quiz. That make it 6. This is going to be 5 topics. Then we have to give you 2 problems from one of these topics, and that's 2 problems are going to be from this integrating factor. So to make it 6 problems, okay? Separable, linear, Bernoulli, exact, integrating factor of type 1, integrating factor of type 2. That would be 6 questions that you need, okay? So this is it. So again, integrating factor, I think it's in 2.4. Okay, or part of it. So what is very popular? What is integrating factors? Going to be a function. You see the definition is if you have a function usually denoted by mu, like the one that you did for the, okay, you did the case with the linear equation that you did, that's integrating factor. That was easy, so that's why we talk about it. Great. So a function mu, which is going to be a function of x and y in general, is called, okay, this is going to be called an integrating factor. Integrating factor. Okay, for the differential equation. Integrating factor for this differential equation. The differential equation. This is the format that we're going to use, m of x comma y dx plus n of x comma y dy equal to the 0. It's going to be integrating factor if this equation, you see, if you multiply both sides by mu, the result of the equation is exact. Is if the equation, see, I multiply both sides by mu, it's going to be mu times m of xy dx plus mu times n of xy dy equal to the 0 is exact. So it's going to be called integrating factor. If you multiply both sides of the equation by mu, the resulted one is happen to be exact equation. That's integrating factor. Yes.
Is that E ln plus? Oh yeah, the first line.
Mu.
Mu m.
Mu times m, the function x and y.
E ln, or is
No,
that
no,
just
no.
ln?
You see, the function is m of x and y dx.
Oh, I thought it was okay.
No.
My bad.
You see, in short, this is it. A mu m dx plus mu n dy equal to the 0. This is the result of the equation that usually we write in this. Okay, let's check one example to see, to get the feeling of the meaning, and then we are going to give you 2 conditions. You have a set of problems in your book of this format. You better do it, one of them at least. They give you the integrating factor. They ask you to show that the function, okay, show that the function mu of x comma y equal to x times e to the x is an integrating factor. Is an integrating factor for this equation. For the equation. This is the given equation. X plus 2 times sine x dx plus x cosine of y dy equal to this. We want to prove that this mu is an integrating factor for this equation. So what we're going to do is you multiply both sides by x e to the x, then check the condition for the exact for the resultant equation. If it's going to be true, they must be equal to each other. Because then you can solve the equation. This is the way we are going to do it. Okay, are you ready? Solution. Multiply both sides of the equation by that. See, multiply both sides of the equation, both sides by that mu, by mu, which is equal to the x e to the x. Okay, that's it. If you multiply by both sides, so I have x e to the x. I have to multiply by this. I multiply by the x plus 2 sine x dx plus x cosine of y dy. Multiply by the other side, x e to the x. I just write it down, you know what's going on. So multiply it for the first one, you have to distribute it. Okay, and then you do it. So if you multiply this one, for the first one, you get x e to the x times x plus 2 sine x. Okay, this must be, sorry, this must be sine y. Make this one into the y. Surprise if you go y. Okay, that's the y, and the other one is x cosine. Okay, multiply inside. So that would be sine y dx. Multiply the second one, x times x would be x squared e to the x cosine of y dy equal to this. When you multiply that with the resultant equation. Now you have to call m and n, check to see if this is going to be, okay, this is going to be your m. And this is going to be your n. Find my and nx so that they are equal to each other. Okay, you can do it right away. I just repeat it. You don't have to. So this is your m. You don't have to simplify it because you're not going to do much. See, this is m. You know that in case of the m, you find the derivative respect to y. The only y that you have is sine y. Derivative of sine y would be cosine y. Everything else is a coefficient, is a factor. So the result would be x e to the x times x plus 2 cosine of y. That's m sub y. Any question? Take n. What is n? N is x squared e to the x cosine of y. That's your n. Now you have to find the derivative with respect to the x. You have to apply the derivative with respect to the x, cosine of y, cosine y stay as is. Then you have to apply the product rule to the x squared e to the x. Okay, differentiate respect to the x. Differentiate respect to the x. Okay, the product rule, derivative of the first times second, derivative of x squared is 2x. So it's a 2x e to the x cosine of y. That's the derivative of the first times second. Second first, e to the x never change. So it's going to be plus Okay, x squared e to the x cosine of 1. You know, if you factor out x, this is going to be the same as each other. So you can factor x e to the x e to the x. You see, it's going to be, if you factor out x e to the x cosine of y, you get the leftover of the x here and the 2 over there. So as you can see, my is equal to the nx. So this result of the equation is exact. So this means, okay, so this means mu is an integrating factor. Mu equal to the x e to the x is an integrating factor. And so you may be questioned, we may give you a function and ask you to show that it's integrating factor. We haven't asked you to solve the equation, so it's done. Just do the job and show that this condition satisfy. Any question? Now we want to solve it. Okay, we want to know how we're going to find the integrating factor in general. Suppose you don't know it, how we're going to find it. There's a nice method that you can create the formula for yourself, anything you like. I show you. That's nice to know. Okay, are you ready? So how are we going to find an integrating factor for a given, for the given equation? With 2 cases, 2 problems. That's it, and we're done. Now, finding integrating factors. How are we going to find? Finding integrating factors. How are we going to do it? Okay. Suppose in general an equation is given to you and you would like to force a function mu to be your integrating factor. Let's see if you want to force it, what you need to do to that function. Okay, so there you are. Suppose you start it over. Suppose the function. You don't know anything about this function, but suppose this does exist. Suppose the function mu equal to the mu of x and y is an integrating factor for this equation. For the equation, okay, for the equation, I make it short, this equation, m dx plus n dy equal to this. Okay, suppose it's, you know, you want to force, suppose this is given. Okay, what does it mean? This means if you multiply both sides of the equation by mu, the result of the equation is going to be exact. Okay, so therefore, this equation, multiply both sides by mu. So, you know, we can write mu, this is it. It's going to be mu. We can multiply the mu by original one, m. This is going to be mu m dx now, plus, multiply this one by mu, and that's going to be n dy is equal to the, okay, is equal to the 0, is exact. Okay, so what does it mean? It's exact. It means it satisfies the, okay, the exact condition. What is the exact condition? The exact condition is this new function. The derivative of this new function with respect to the y is going to be equal to the derivative of the other function with respect to the x. Okay, so it's exact, and so this is what you're going to have. Derivative of this function with respect to y. I write it on this form. Partial derivative is equal to what? It's going to be equal to the derivative of the other function with respect to the x. So mu n respect to the x. I'm going to make a formula. Okay. Now let's go on. This is a product of 2 functions. So apply the product rule. And you apply the product rule respect to the y. Derivative of the first times second, second first. Derivative of the first one would be mu respect to the y times the second function m plus derivative of the second times first. Second times first, it's going to be mu times m respect to the y. That's a product rule for the left. Derivative of the first times second, second first. Any question? Do the same thing here. Derivative of the first times second is going to be mu sub x times n plus derivative of the second times first, nx, derivative of n respect to x, times mu. You see, that is going to be a very popular equation. Okay, so if the function is supposed to, if the function can be satisfied this condition, this is what you are going to get. So for some purposes that will make it easy, what I'm going to do is, I'm going to move these two together. See, look at this. So I rewrite it. I'll rewrite it as what? Rewrite it as mu times m times y minus nx times mu, and on the other side, mu xn, okay, minus mu ym. Okay, I got this equation. So what I do, I'm going to factor out the mu here. So I give me mu m sub y minus n sub x. And on the other side, what I'm going to get is going to be mu xn minus mu yn. You see, that's going to be the key equation if you want to do this type of problems. So this means if a function is going to be integrated function, factor, that function must satisfy this condition all the time in any differential equation. So this means mu is an integrating factor. Integrating factor. Okay, if and only if. If and only if mu satisfies the star equation. You see, a star equation, look at this one. You see, these are known, my, nx, nm, all of them, you know it. The only unknown of your problem is mu. So if you look at this, this is a kind of differential equation in terms of the mu. You see, you have the mu, derivative of the mu respect to the x, derivative of the mu respect to the y. So instead of solving the differential equation at the beginning, you have to solve this equation, differential equation for mu to be able to do it. But what is your difficulty? The difficulty is, what is the derivative that you have for the mu? You see, derivative of what? That's a mu. Mu sub x. If you can call mu sub x mu prime, then you'll be able to solve this equation. But this is partial respect to the x. And this is partial respect to the y. So as is, it's difficult to solve because it's a partial differential equation. So what can you do to change this equation, a star equation, from a partial differential equation to a differential equation in terms of the mu? Everybody understand the question? You see, this is mu. If instead of this mu sub x, if I have mu prime, and if I don't have this one, so look at this. If I have a mu prime here, mu prime, this equation would be easily solved for mu because separable variable. Yes?
Do you integrate with respect?
No, you have to impose a condition on mu so that your mu x would be mu prime and mu y would be 0.
Multiplied by mu y.
No. You see, your function is a function of two variables, x and y. You want to make it so that the derivative of that function respect to the y to be 0. So what your function, and you want the partial derivative respect to the x to be derivative, mu prime. So what condition can you impose on your function? You get this one. You see, when you would like to have the derivative respect to the y to be 0, one way to do it is just forget about the y. So if you consider your integrating function to be exactly a function of x only, that's easy. Partial derivative with respect to the y would be 0, this mu would be mu prime, and then quickly we can find the mu and we are done. Or you may like to keep mu sub y. If you would like to create mu sub y, you don't like mu sub x, you have to impose the condition that your function must be only a function of y. If it's going to be a function of y, the other part would be 0. So that's easily two different cases that we can do. The other one that I gave you need more algebra. A function of x times y, x squared plus y, all of them are possible. And you have to go through this one. And then give you an experience how we're going to do it. So what I'm going to do is, I'm going to divide this one in two parts. We give it two formulas. And instead of going through this proof, we get the condition and you impose the condition quickly on the differential equation. It's going to be either case 1 and case 2. That is going to be the conditions, okay? So there are, I'm going to call it, there are two possibilities because we consider only the two possibilities. So we are interested in this. There are two possibilities. The one that, it can be easy. And you can, you can impose various conditions and get more. There are two possibilities. We call it case 1 and case 2. Case 1, if mu is only a function of x, mu equal to the mu of x, okay, is a function of x only. Okay, that's going to be case 1. As soon as you impose this condition, you have those, the one that you like it, okay? So in this case, you see in this case, mu sub x, partial derivative with respect to the x would be just mu prime. Because there is no second variable. And mu sub y would be 0. Go to a star equation, substitute. A star equation. So your star equation for this case would be what? Would be mu times my and x equal to mu prime times n. The leftover would be 0. Solve this equation for mu. It's an easy differential equation to solve. Okay, so I'm going to rewrite it. It's a separable variable. You see, let's stay with this first. It's going to be mu prime over n. So a kind of a separable variable. This is the way I'm going to write down, divide by mu. So I have separable variable, mu prime over mu equal to what? Equal to the my minus nx, okay, over n. You see, it's a separable variable. But the thing is, the function to the left is only a function of x. So the function to the right is also going to be a function of x. This is the way we check it. When the equation is given to you, you check the my and the nx. If they are the same, it's exact. If they are not the same, subtract it. Subtract it divided by n. If the result is going to be a function of x, then you can use this formula. So we usually call this one phi of x because it is going to be a function of x. Then we solve for the mu prime. It's separable variable. So it is going to be mu prime over mu equal to the phi of x. Integrate. If you integrate it, what's integral to the left? It's mu prime mu dx equal to the integral of phi x dx. Phi x, it's customary to write it as a phi. You know that is u prime u. It's a ln function. Yes.
Mu prime, so
Mu
integral
prime.
mu
Yeah,
prime
yeah.
over
We integrate
mu.
both sides.
Does that say like dxc or what does that say?
No. Sorry, it's equal to.
Oh, equal to, okay.
I integrate both sides. Okay. Integrate the left and the right equal to each other. Now integral to the left would be what? U prime u. So u prime u. ln. It's going to be ln of mu. Okay. So are you done? Next page to finish it. To finish it, we have, this is the proof. We have the formula. Okay. Remember, you are looking for mu, so we give you a formula to find it. Then you are not going to be surprised because it's going to be like the linear function that we did before. Okay. So there you are. The term to the left would be ln of the mu, or if you like, absolute value of mu of k. Okay, and this would be just phi x dx. And if you want to find the mu, write down an exponential form that gives you something familiar. Mu of x is going to be e to the integral of phi of x dx. You see, this is going to be your integrating factor. Is an integrating, okay, integrating factor. Nice formula. Look at this one. You can repeat it for the y. If you repeat it for the y, let me write down as a theorem, then I'll come back and explain it again. This is it. So you prove this, and this is the one that you're going to use. Two cases. Case one. This is the way we're going to do it. Say that a differential equation. The differential, okay, differential equation m dx n dy equal to the 0 as an integrating factor of the form mu equal to u of x, means just a function of x. A function of x if, okay, if the quantity, this is the quantity that we talked about it. What is that quantity? Quantity is m sub y minus n sub x divided by n is going to be a function of x that we call it phi of x. Okay, is a function of x. So you check this one in your equation first. Function of x. So you already got m sub y, n sub x. They are not equal to each other. Subtracted, divided by x. If you divide by x and y disappear, the result is going to be, should be a function of x. So you may get 1 over x, or you may get 1/2, 1/5. No y in it, okay? If this is going to be the case, we say, oh, there you are. In this case, u equal, or u of x equal to the e to the integral of phi x dx is going to be integrating factor. Is an integrating factor. That is case one. Any question? Ready for case two? See what's going to be different for the case two. Just want you to refer to that historic question again. Have a look. See, that was the start equation that we talked about. And this one. When it's a function of x, this part was 0, we divide by n. If it's going to be a function of y, this would be 0. Then you have to divide by negative m. This is the difference, negative m. So case 2. So if you cannot find it with this, you will say it in practice, which one is easier or which one would give you the result. So case 2. Case 2, the same thing, the differential equation. So a differential equation in f dx as n dy equal to the 0 as integrating factor as a function of y as an integrating factor of the form okay, this time mu equal to mu of y, function of y. If the quantity, this time the quantity is this. The top is the same, my and x, and you divide it by negative m. This must be a function of y. Some people, even you, I think your book is the same. Some people, they multiply the top by negative, consider this one as nx minus my. That's easier to remember. The top is the same. Okay, the top is the same, but for the first one, you divide by n. You divide by n, if it's not working, you go back and divide by negative m. So 2 conditions. So in this case, either it must be a constant or it must be a function of y. Cases. If it's going to be equal to the 5, you can call it the function of y, because that's the second case, okay? That's it. This is going to be an integrated, this quantity. So it's going to be integrating factor if this is going to be a function of, is a function of again, the same thing. As soon as to find out, say in this case, okay, in this case, your integrating factor again would be the same thing. Mu equal to the e integral of phi of y dy. More often we call it phi of x and phi of y, and it's like integral of px dx that we did before. Is an integrating factor. Is an integrating factor. So you can get a chart and you can check various functions. The most famous one are going to be these two. The other one, x times y, is also famous. I used to call that one as well, but it's very rare, but at the end of the day, they give you a table and you check it for all the formulas. If it's going to be my minus nx, the bottom would be something like x times m minus y times n. Then your integrating factor will be a function of x times y, for example. This, if you like algebra. But we are going to focus on this one. Okay, any question? Let's do it. We give you 2 problems, one each, and then, so the procedure is this one. You check the m by and the nx. They are not going to be equal to each other because you've been asked for the integrating factor. Or in general, if you want to solve it yourself. So you check the separable, it's not, the linear is not. You check exact is not. How about integrating factor? Okay, you check this difference and you check it. Yes.
Can you go through that list again one more time?
Which one?
The list that you just said of like, oh,
Separable, exact, and linear.
separable, exact.
Separable, linear, okay, separable, linear, exact, integrating factor. Because Bernoulli would be a part of the linear. There's only one more group, homogeneous. We're going to talk about it. Okay, I go with your boy. Otherwise, I usually go with the homogeneous before the exam. But for the homogeneous, we have different possibilities. But this is the way we do it, okay? For the integrating factor, sometimes they ask you, they give you the hint. Okay, so let's do it. You need two problems, okay? So this is what I have, and we have the one on your practice one that we can check it quickly. So this is, that would give us 5 topics for 6 questions on the quiz. And as 5 questions, we repeat it on your test number 1. Then you can forget it. Okay, so this is it. We give you the hint. This is the way I'm going to give you the problem. It says solve. Okay, this is exactly how we're going to give you. Solve each equation by finding an integrating factor. Okay, integrating. Fine. So this means you are, not only showing that there is an integrating factor, you have to solve the problem too. Okay, it takes a little bit of time. Be prepared. Okay, the first case. This is the first one. X plus y dx plus, okay, plus x ln x ln x dy equal to this. Because of the ln, they give you this extra condition, x positive, y positive. Make sure you know the functions are well defined. That's it. Okay, are you ready? Pick the m and n and start working on the conditions. Okay, this is going to be your m, and this is going to be your n. So that's it. Solution is going to be m is x plus y. You know that from m, you have to find m sub y. Differential with respect to y. X is isolated, derivative would be 0. Derivative of y would be 1. That is m. Okay, we have the n. So n is equal to the x ln x. You have to differentiate with respect to the x. You have to use the product rule. Derivative of the first times second, second first. Derivative of the first one, derivative of x is 1 times the second ln x. Plus the derivative of the second times first. Derivative of ln x is 1 over x. Okay, times the first function x. So you simplify these two. So that give you ln x. Okay, that give you ln x plus 1. So that would be your nx. Any question? As you can see, they are not equal to each other. So my is not equal to the nx. Now we would like to look for the integrating factor. Find this difference first, because the top of the formula that we gave you was m sub x minus 1, okay? So find m, so that's the next step. You find my minus nx. My is equal to 1 minus nx, is minus ln x plus 1. That gives 1 minus ln x minus 1. So that gives you negative ln x. So my minus nx is equal to the negative ln x. That's the top of that fraction that we're going to compare for us, okay? Now check to see. You have 2 options. You can divide it by n, simplify it, or you can divide by m or negative m to do it. Yes.
So because my and nx are not equal, that it's not an exact equation. So what does that mean? Like what's an
Because if it's going to be exact equation, you don't need integrating factors.
Oh, okay.
That's why. See, that's why we check it. It's not going to be because it's the exact. You don't need integrating factor in that case. You can get any function you like because it's already exact. Okay, that's why we know. That's just to remind you. Maybe do it. Okay, now check which one is better. Dividing by n or dividing by m. You see, if you're dividing by m, it's very bad. M is x plus y. You cannot simplify it. And if you divide it by n, see, you divide by n, ln x would cancel out, leftover would be x, the function of x be done. Okay, so this is the way you check. You have to check it, which one is going to be better, okay? So we decided that if we divide it by n, that would be better. So divide, simplify. So that give you negative ln x, and you have the x ln x. If you simplify that, give you negative 1 over x, a function of x. Quickly, you call it phi of x. You don't have to explain anything. It means you realize that this is going to be a function of x, and then we know that there is an integrating factor, and we continue to find it. Okay, any question? So what is going to be an integrating factor? The integrating factor would be, so the next step, mu equal to e to the integral of phi of x d of x to find the integrating factor. So substitute, go ahead. So you have to find this one. You can do it as is, but you better find the integral of phi of x dx first. So that will be negative 1 over x, okay, negative 1 over x dx. And that will be negative ln x. Since you want to simplify by, you know, it's going to be equal to the ln of 1 over x. You move the negative 1 up, x to the negative 1 would be 1 over x. So e to the, okay, so mu would be what? Would be e to the ln of 1 over x. The result would be 1 over x. So mu equal to the 1 over x is going to be an integrating factor. Is an integrating factor. It's the way you are going to find the mu. Any question? So as soon as whatever that quotient, you simplify it, it's going to be 5x or 5y. Yes.
So on all the examples that we've done, they're all integrating factors. What would an example look like where it's not an integrating factor? Will we come across
This quotient over here,
Okay.
can't simplify it.
Okay.
You see, m by minus nx over n. If it's going to be something other than the function of x, okay, it would be impossible. It's not the case that all of them you will be able to do it. But since they said solve the equation by finding the integrating factor, so this it must have one. Okay, so it must one. So it's going to be the case 1 or case 2. So that's just okay. That's a method that we try. Okay, but you know, in this case it's different. Okay, you are not done. Now we have finding the integrating factor. Now we have to solve it. So what you have to do is you go back. You multiply both sides of the equation by 1 over mu. The result is exact. Start working on the exact equation. Remember, you are not done. You have to solve the equation. So the next step is going to be solving it. To solve the equation. Go back, multiply both sides of the equation by 1 over x. So this is, I repeat the equation, x plus y dx as x ln x. Okay, dy equal to the 0. Multiply both sides, 1 by 1, the terms by 1 over x. Okay, start multiplying. So for the first one, I just write it down. You can write it in short form. 1 over x times x. It's going to be x over x, y over x, dx, plus x ln x divided by, okay, divided by x, dy equal to this. Okay, multiplying by 1 over x is like dividing by x. Now simplify, these two would be done. Would be 1. That give you 1 minus y over x dx, okay, plus ln x dy equal to the 0. And now you know that this is exact. You don't have to check it again. Is exact equation. Yes,
Why is it 1 minus?
because I made a mistake.
Okay.
It's plus. Okay. Remember, you don't have to check. I've seen some people on the test. they try to show that this is exact. You know it, okay, because you find it through the integrating factor. So automatically go for the solution part. You don't have to check it again. Okay, it's gonna be exact, and you know that you have to find the function. Okay, so we go to the last case, last part, finding the f. We need to find a function f of y. Quickly write it down. That system of the equation that we have, round f, round x, equal to the m, your m is this, 1 plus y over x. Then round f, round the y is going to be equal to your new n. Your new n is ln of x. Any question? So that's your question, your equation number 1 and 2. Start integrating. You get this one. You can check the first one or you can check the second one. Okay, doesn't matter. I did the second one. You remember the second one, differential respect to the y, integrate respect to the y. So it's easy or easier. Okay, any question? So I start number 2, taking the integral of ln x respect to y, which is going to be just y. So solve it. I take it from number 2. So in number 2, I integrate respect to y, f of x, y, integral of ln x dy. Ln x is a constant, integral of y1 is just y. So that give you y ln x. It is going to be a constant. Since integral respect to the y, your constant is a function of x. You can call it g of x, h of x, it doesn't matter. So I go with the g of x. Okay, so far I have f of x, y is equal to the y ln x plus gx. So now I'm going to find the gx. To find the gx, you have to differentiate this one respect to the x and compare it with the equation number 1. So differentiate respect to the x. So that give a round f round x equal to y is a constant, derivative of ln x is 1 over x. So that gives y over x, g prime of x. Okay, I differentiated respect to the x. Now I compare it with the equation number 1. Equation number 1 was round f round x, which was 1 plus y over x. So compare them together, or let them to be equal to each other. Any question? So these are going to be out. The equal term will be out. The leftover, g prime of x equal to 1. So we get the g prime of x equal to 1. And integrating g of x. Okay, g of x would be just 1. Would be x. Okay, integral of 1 would be x. So go back. Introduce your function. So f of x, y would be y ln x. Y ln x plus x. This is going to be the function that satisfies potential function, if you like. But it equal to the constant to get the solution of the equation. So the general solution is f of x comma y equal to the c, which is the same as y ln x plus x equal to the c, and then we're done. Okay, you know, it's nice procedure, but it takes a little bit more time. Manage your time when you want to do it with these numbers. Okay, any question? So we have going to give another one, then we give a break. Okay. So again, you know, the procedure, you find the m, y, and x, they are not equal to each other. Find the difference. You have 2 choices. You have to simplify it. You either divide by n, get something nice, or either divide by m, negative m. Give it negative. Yes.
So in the beginning of the problem, when you're determining how to divide by n or negative m, you just you choose whichever is best. Or...
Yeah. There's going to be only one possibility.
Okay.
Fine, because they ask you solve by integrating factor. So you have to see which one is the one that you can simplify. Because for the first case, you can have only a constant or a function of x. If you get 5, that's fine. We call it the function of x. You should have y. Okay, check the second one. We see you can compare them together. Okay, so let's check another one. The second case that we have. For the second one, I think this is one of the one on the left. Not quite sure. Okay, that's it. 6xy dx plus 4y plus 9x squared dy. So this one, again, it's not separable, it's not linear. So, they give you the hint for the exam. So bring the condition m and n, check. So this is your m, and this is going to be your n. Okay, so m is equal to the 6xy. Find derivative with respect to the y, so that gives you 6x. Then you take your n, which is 4y plus 9x squared. Find the derivative with respect to the x. Respect to the x, yes.
How come the m and the n aren't switched? Because I thought you're supposed to do a partial differentiation in terms of y, but the m that we chose.
In the general term, the equation is m dx plus n dy.
Thought it was my and n.
No, this is the equation, not that procedure. That's a formula then, okay? Just the formula, you find the m and n, then you go by my and the nx. Okay, so nx, derivative with respect to the x would be what? Would be 18x. Okay, as you can see, they are not equal to each other. So we can go on for the integrated factor, find the difference, and try to simplify it. My minus nx is going to be what? 6x minus 18x. That gives me negative 12x. See that give me negative 12x? Now check to see what I'm going to do with it. You can divide it by m to simplify it, or you can divide by n. If you divide it by n, you are not going to get anything. You cannot simplify it. But if you divide it by m, see if you divide it by m, this x and x would disappear. The result would be a function of y. And you know that in case of the m, you always get the y. But we divide by negative into the formula, okay? So this is how you pick which method is applicable to this one. So this is going to be case 2, okay? So my minus nx divided by negative n. So that gives you negative 12x on the top, 6xy then. Now you simplify it, you see the x would disappear, and the 6 and 12, so the result would be negative 2 over y. As you can see, this is a function of y. So we can call it y of y, and then continue. Now you know that they are going to be integrating factor, which is a function of y. Okay, any question?
Should 6xy be negative because it's negative m? Should 6xy be negative because it's negative m?
Oh, yes, you are right. Thank you. So it's a negative, yes. I missed the negative, so this would be positive, which is very important. Okay, very good. 2 over y. Okay, so now we know the rest. Now we know that we have mu equal to the integral of y dy. That would be our integrating factor. Start working on the integral of 5y dy first. So integral of 5y dy is the integral of 2 over y dy. You know that gives you 2 ln x, 2 ln y. 2 ln y, move the 2 up, y squared. Now find the mu. So mu would be e to the ln of y squared, which is equal to the y squared. So mu equal to the y squared is an integrating factor. An integrating. Okay, it's going to be an integrating factor. Okay, any question? Now the solution of the equation. You go back, you multiply both sides by y squared and work for the, okay, working for solution to the exact equation. So equation is 6xy dx plus 4y plus 9x squared dy equal to the 0. I'm going to multiply both sides 1 by y squared. Multiply each term 1 by 1 is 6x y cubed, 6x y cubed dx plus multiply inside parentheses here that give you 4y cubed plus 9x squared y squared dy equal to this. And you know that this is exact. You don't have to check it. Okay, now I start working on the solution of the exact equation. So we are looking for the function f of x comma y that satisfies this condition. Round f round x is going to be equal to the new m. You see, this is your new m. This is your new m, if you like, for this part, and this is going to be your new m. And you want to solve this, this equation. Okay, so round f round x is equal to the 6xy cubed. That would be your equation number 1. And round f round y equal to the n, which is 4y cubed. 9x squared y squared. This is going to be equation number 1 and number 2. Start integrating the first one. The second one, I'm going to pick the first one. I integrate the first equation by x. So I have a constant as a function of y. Okay, so solving this. So I pick this one. So f of x comma y is integral of 6xy cubed dy. With respect to the y, so y cubed would be y to the, okay, would be y to the 4th to get this number. Okay, just make sure you get 6xy. Yeah, that was a 6xy cubed. Okay. So we integrating, I have to integrate respect to the x. You know that there's something wrong. Okay, integrate respect to the x side. Because I picked the first one. So integrate respect to the x. No, if you start with the second one, integrate respect to the y, but the first one x. Now that's easier. 6x would be what? It would be 6x squared y cubed divided by 2 plus a constant. Now constant would be a function of y, g of y. So far, f of x, y would be what? Would be 3x squared y cubed plus a g of y. Okay, this is a kind of equation number 3 that we have. Now the question is going to be, what is g of y? In order to get the g of y, you have to form the second equation. You have to find the derivative with respect to the y and use that one. Okay, so find the round f round y. With respect to the y cubed 3 times 3, 9, x squared, y squared. Okay, plus g prime of y. And you already got the round f, round y from the equation number 2. So from the equation number 2, you have the round f. Okay, you have round f, round y is equal to the 4y cubed plus 9x squared y squared. Compare them together. Drop the equal parts. Common one. Let the leftover to equal to each other. Leftover is going to be g prime of y, which is 4y cubed. Now integrate respect to the y to get the g of y. So the g of y would be what? Would be 4y to the 4th over 4, which is y to the 4th. Okay, so finally, the function is f of x, y equal to 3x squared, y cubed plus g of y, which is y to the 4th. That is your function, and the solution of the equation is when you let it equal to the c. The solution is x squared, y cubed plus y to the 4th equal to the constant c. Okay, it's a nice format, nice equation. Yes,
How come it's equal to the constant?
you see, remember that function f that we find, the differential of the f is your differential equation that you have. And on the other side of your differential equation is 0. So this function, differential of this function is 0, or the derivative of the function is 0, so the function must be constant. So we let it to equal to the constant because we let it to so that's it. Okay, can I have a short break then? I'll give you, a couple of solution of that quiz, but otherwise, what's the solution of that? We'll see. Equation. Next one is a linear equation. Linear equation. Okay, the third one is Bernoulli equation. Okay, Bernoulli's equation. The fourth one is going to be exact equation. We ask you to prove that this is going to be exact and just find it, exact equation. Okay, and the fifth one is integrating factor. They give you one of them. It may be case 1 or case 2, because 2 would be too much. Okay, so that would be integrating factor. Must know the definition of integrating function. If one function is given to you, they ask you to check to see if that's going to be an integrating factor. You must know that. Multiply both sides of the equation and then you prove it. And we give you one and we ask you to find integrating factor and then solve. So if integrating factor is already given, you just multiply and prove it. And if they ask you to find it, it's going to be either case 1 or case 2, not both.
Our Sean.
So you simplify that expression as y minus n x and just go.
No, you wouldn't know.
I was like, oh, are you talking about someone else?
Okay, so this is the topics on the quiz. One from each separable equation, linear equation, Bernoulli equation, exact equation, integrating factors. I know there are 2 cases, but we give you only one of them. But we may ask you the kind of, because you have this set of problems in your book there. We may give you integrating factor and ask you to prove that it is integrating factor. If the function is given, you multiply and you check the condition. And the other part is going to be, we give you one of these equation and you test it for yourself. It may have an integrating factor as a function of x or a function of y. You have to find it and put it together. That's 6 questions for this, okay? And we repeat it again on your test. Test number 1, 11 questions. This is 5. 6 is going to be the rest of this chapter, okay? It's going to be all differential equation of a first degree when we get to the test 1. Just a preliminary of a second, right? So this is it. That is your practice quiz. I do whatever I can, but I finish these lecture notes with the rest of the solution of the practice quiz number 1, and then I post it for you. You can check it. Okay, now the first group are separable one. Okay, question number 1, you've been asked solve each equation. I'm not going to say that it's separable, but it's clear that it's going to be separable. Okay, they are very straightforward problem. So the first one is dy dx equal to the x to the 4th 1. You see, this must be a function of x times it by a function of 1, or divide it, because you should be able to group them together. X to the 4th is function of x, so y is a function of 1. So it's separable. Just cross multiply it. You can see it if you like, to cross multiply it first and then decide. So the equation is separable. Okay, the equation is separable. Even if you cannot find out at first, cross multiply. So if you cross multiply, that gives you x to the 4th y dx equal to the dy. So you have to put the y's together and the x together. So x to the 4th dx, y is an extra, so divide by y. Okay, divide by y. So that gives you x to the 4th dx equal to the 1 over y dy. As you can see, it's the equation with the separable variables. Integrate x to the 4th dx, 1 over y dy. That gives you x to the 5th over 5. That gives you ln of the absolute value of y. You can add the constant c over here. It's a final answer. If you like to multiply by 5, you can do it. That's optional. Okay, 5 ln of the absolute of y plus c, the final answer. Okay. Now, some people like to put the c to the other side, write down an exponential form. Don't do it. It's done. Y is here. Okay, that is number case 1. Any question? Just a couple of them that you may have to do a little bit more together. Okay, let's just give you one more. And it's very similar to the one that we did, okay, during the lecture. So I check number 3 again. These are easy. You can check the solution that we post. Okay, number 3, part 3, of course, dy dx is equal to the e to the x y, and that's a 1 plus a y squared. Look at this one. Again, the function to the right is just a product of 2 functions. You see, e to the x is one type, y times 1 plus y squared is the other one, okay? If you take this one, you see this is a function of y, and this is a function of x. So it's a product of 2 functions. Since it's a product of 2 functions, it's a separable equation. So cross multiply, that gives you 1 plus y squared dy is going to be equal to, okay, y times e to the x dx, that's y. Then you would like to have the x and the dx together, so this y is extra, divide by y. Okay, divide by y. So that gives 1 plus y squared over y dy, and this is going to be e to the x dx, separable variable. Okay, integrate 1 plus y squared over y dy is equal to the e to the x dx. I'm going to integrate this one. Divide or just break, yes. We can 1 over y plus y squared over y. Break it. This is of course easy, e to the x plus c. Over here, these two would cancel out, so that give you 1 over y plus y dy equal to the e to the x plus. And integral is easy, ln of the absolute value of y plus 1/2 of the y squared equal to the e to the x plus c, and then do that. Okay, so it's usually easy integral. Okay, then you check the rest. There is only one that, see, we did this one. Before number 4, you have to do kind of factoring. You better check the solution because it takes times. So that is case 1. The case 2 for the linear equation, this can be tricky. You have to be careful. Okay, case 2. Problem number 2. Solve each equation, linear equation. Solve each equation. They are going to be all linear. You know the procedure to do it. The tricky one is part C. Check the other solutions. Let's see what's special about this one. It's a x, y prime. Okay, x, y prime plus 1 plus x times y equal to the e to the x, e to the negative x, sine of the 2x. So this one, you know that linear equation is y prime plus pxy equal to the qx. So what are we going to do first for this one? First thing to do, y by x, remember. All the formula for the linear equation in this course, start with, you know, the coefficient of the y prime must be 1 all the time. Otherwise, you cannot use those formula. So that's step 1. You have to divide by x. Okay, divide by x. Divide by x, that give you y prime. That would be 1 plus x over x, y. This would be e to the, okay, e to the negative x sine of the 2x divided by x. Now it's a linear equation. Okay, it is linear. It's linear with, you know that in linear equation, this coefficient is going to be called p of x, which is 1 plus x over x. And the other side would be q of x. You know that we solve this one by that. Now you know it, integrating factor. So what you need to find, you find the mu. Remember the mu is e to the integral of the qx, px dx. So you have to work on the integral of the px dx. So integral of the px dx is equal to, is equal to the 1 plus x over x dx. Again, you have to break this one. You're able to do it, you divide, it's going to be 1 over x plus, as we did for the other problem, x over x would be 1 dx. Okay, carefully integrate it. Integral of the first one would be ln x. The second one would be x. No constancy because it's integrating factor. You can assume that the x is positive. No worry about the absolute value because we are going to check it over here. Okay, so the mu is going to be e to the ln x plus x. You have to break it to simplify it, e to the ln x times e to the x. E to the ln x would be x. So we get x e to the x. Okay, so that gives you your integrating factor, x e to the x. Pick this one because of this integral and the fact that you have to divide by x. Okay, now we go with the procedure of finding the solution of a linear equation. Remember formula, y equal to 1 over mu integral of ux times mu dx. Substitute, simplify. So that give you 1 over mu. Mu is x e to the x integral of the qx e to the negative x, the sine of the 2x divided by x times it by mu. Mu is x e to the x. Then the dx. Now nicely would be simplified. The x and x would cancel out. Get e to the negative x times e to the x. You know that's going to be 1. So these two would be 1. So the leftover would be only x e to the x integral of sine of the 2x. Any question? You know that if you have a sine is a negative cosine. So this is going to be 1 over x e to the x. Integral of the sine would be negative cosine of the 2x, then you have to divide it by 2. That's after you plan. And of course, the constant c. So that would be the final answer, even if you multiply it. So you can leave it as is, or if you can multiply it, the negative cosine of the 2x over 2x e to the x plus c over x e to the x as the final answer. That's the best case for the linears. Just make sure you divide it by x to get the number. Okay, so 1 is straightforward for the linear. Any question? So that is the linear equation. Case with the exact, I did the similar one and the integrating factor. Back to remind you one for the Bernoulli one. Okay, so one problem from Bernoulli. Okay, this one. Okay, number 5, solve the Bernoulli equation. Bernoulli's equation. You have 3 here, I give you 1. Okay, swap them out the same. I'll just do the first one. X y prime plus y equal to the 1 over y squared. Remember, Bernoulli equation is of this type, y prime, pxy at qx times a power of 1. That is Bernoulli equation.
The QX or CX?
This one. Oh, qx, yes, it's q. Okay. So you have to divide by x first, because that's the x by prime. Okay, make sure they're always write it down as a money equation. Normalize the coefficient. Okay. So we divide by x first, y prime, 1 over x, y equal to, divide this one by x, so it's going to be something like 1 over x times 1 over y squared. So that in case you need it. Then you know that. What we are going to do, we have to get rid of this y squared here. In this case, we multiply both sides by y squared. Then you go with the substitution z to change it to the linear equation. You have to get rid of this y. So you divide by 1 over y squared, which is the same as multiplying by y squared. So multiply both sides by y squared to remove that y from the right. So we resulted in y squared y prime. 1 over x, that is y times y squared would be, I write it down. And this is going to be 1 over x. Now we end up with y squared y prime, 1 over x, y cubed, equal to the 1 over x. You see, remove the y, remember you need a substitution. The substitution would be you are going to take this one to be z, and then try to change this one into the z prime. This is the way we do it. Then it can be linear. Okay, so the next step is you take the y to be y cubed, z to be y cubed. And you have to find the z prime. Differentiate, chain rule. So that gives you 3y squared times y prime. And you need only y squared y prime. So you have to divide by 3. So y squared y prime will be 1/3 of the z prime. Which will again normalize it. Go back to this equation, substitute. Change the equation into a linear equation. Okay, so this would be the result. Y square y prime would be 1/3 of the z prime. That's 1 over x of the z and 1 over x. You want to change this one to the linear respect to the z, so 1/3 is extra. So you divide by 1/3 or multiply both sides by 3. Get rid of that coefficient to have officially a linear equation. So it's going to be z prime. This would be 3 over x z. And the here would be 3 over x. So this is a linear equation. So it's linear. It is a linear with respect to z and x. Okay, that's a role of the Bernoulli equation. It's going to be converted to. Now we have to work on this one. So for this linear equation, p of x is equal to the 3 over x, and the q of x is also 3 over x. So you have to find the integrating factor, mu. So we need integral of px dx. So integral of a px dx is 3 over x dx. 3 ln x or ln of the x cube. Get the mu. Mu is going to be e to the integral of a px dx, which is e to the ln cube. Ln of x cube, which is x cube. So that's your mu. Okay. Remember the equation, the unknown is z. So solution of the equation respect to the z. Z equal to 1 over mu integral of q of x. Okay, that's it, q. Q of x times mu dx. So 1 over x cubed integral of qx, 3 over x, times mu, which is x cubed, and then the dx. So it's going to be 1 over x cubed, simplify the inside. Okay, that's a 1 over x cubed. So that gives you 3x squared dx. Okay, so what's going to be z? Z is 1 over x cubed. Integral of 3x squared would be x cubed again. It's going to be x cubed plus c. So you multiply inside. So that gives you x cubed over x cubed. That's c over x cubed. So the first one would be 1. So we get the z. Is equal to the 1 plus c over x cubed. Or c x to the negative 3. Some people they like it. That's it. And you're not done, you have to find the y. What is z? Z is y cubed. Z equal to the y cubed, so that's it. So y cubed would be 1 plus c over x cubed. It's done, but if you like, y would be cube root of 1 plus c over x cubed as defined in our defined. Okay, so we cannot make it complicated. You know. Should be prepared to go through all the procedures. Okay. So get practice to know that you're ready. It takes time, so, okay, but they give enough time to finish those 6 questions. 15 minutes, for example. 1 hour. Okay, so that's it. This is we give the lecture and we give you the quiz for 1 hour at most. 1 hour. If your break will be 1 hour. Then start working on the last group of this equation, the last group of the changes.
Is that actually?